The next method is the quadratic formula. And the quadratic formula, obviously, we all know it. We have memorized it. We have sang it. It's the most important thing because this quadratic formula can solve any quadratic equation. So when all fails, when you don't know what to do, when nothing is working, when you're desperate, if you can use this formula. Okay, and that is, of course, first that we have to have the equation in standard form, ax squared plus bx plus c equal to 0. Then the solution to this quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac. Here's the key thing, all over 2a. So many students makes the division only on the first or only on the last. Remember that the whole thing over 2a. Well, this is just plug and chug. It's hard. It's the only place you might go wrong is in the simplification, which is, just simplifying expressions. So let's see what we're talking about. I did one for you already. Let's look at the next example, 22, solved by the quadratic formula. And here is my equation. Here's something that very few students will do. Only people who are really wants to follow instruction and do well is to write your A and B and C. Why? Because while you are plugging things in, you might, not look at the right thing. You might miss a sign. So it doesn't take that long to just say, okay, A is 2, B is negative 6, and C is 1. And now we can substitute. So x is equal to negative b, so negative plus or minus the square root of b squared minus, here's the key, how we write the next step is also an important step, minus 4 multiplied by a, so this here we're going to put it in parentheses, multiplied by c parentheses, now all over 2 times a. Okay, let's see the simplification. Now negative and negative, so that's plus 6 plus or minus the square root of 36. Remember the negative 6, the whole thing squared is positive 36. And here I have only negative 4 times 2 times 1, which is 8. Okay, all over 4. I'll erase this. So now x is equal to 6 plus or minus 36, take away 8. 36 minus 8 is 28, all over 4. Now 28 is divisible by 4. So this is 4 times 7. So 6 plus or minus. Again, 4 comes out of the square root as 2. Square root of 7 all over 4. Be careful with the next step. Again, that's the common mistakes. We cannot just take this with that or just take this with this. No. The only way we can divide is to make sure that everything is divisible by the same number. And this comes from the fact that in this case, you don't have to do it this way, but I'm explaining why, is to take out 2 as a common factor from the numerator. Then we're left with 3 plus or minus root 7 all over 4. Now the 2 goes into 4 twice, and the final answer will be 3 plus or minus the square root of 7 over 2. Okay? Alright, let's do some more. And the next one is, okay, let's see. Again, the first step is, yes, to move, to put it in standard form. So subtract the 3x, move or add the 5, so it's going to become positive 5 equals 0. Now I'm going to write my a and my b, which is negative 3, and my c. The quadratic formula says x is equal to minus a minus 3 plus or minus the square root of b squared minus 4 times a times c, and it's all over 2a. And this is equal to 3 plus or minus the square root of 9 minus 4 times 4 times 5. 4 times 5 is 20 times 4 is 80. Of course, you can use your calculator, all over 8. And this is equal to 3 plus or minus the square root of 9 minus 80 is negative 71 over 8. Okay, there's something very important that we're gonna learn from here. Okay, so now this is equal to 3 plus or minus, this is root of a negative number, so this is, and this is a prime. So what we have is I root 71 over 8. So the question is this my final answer? And the answer is absolutely not. So if somebody's saying how come, can you answer how come? Because since this is a complex number, we remember that complex number have to be of the form a plus bi. So we're going to have to separate the fraction. A plus bi. If it's real, we keep it under one denominator. Okay, the last two I might do just part of it. Let's see. Or maybe I'll do it all, I'm not sure. If you have something like this one, solve, and then the problem is with the decimal, 0.3 x squared minus 0.6 x. So are we gonna use the decimals? Oh please, of course not. What are we gonna do instead? We're gonna first multiply the equation by 10. So if you multiply the whole equation by 10, so multiply by 10. And this way we get rid of the decimal. And now you can, a is 3, b is negative 6, again c is negative 3, and now x is negative negative positive 6 plus or minus the square root of negative 6 squared minus 4 times a times c all over 2a. So x is equal to 6 plus or minus the square root of 36. Now I have a negative and a negative, so that's going to be positive. 4 times 9 is 36, or 12 times 3, either way. So this is x is equal to 6 plus or minus the square root of. Okay, if you want to add, that's fine. 72 all over 6. Now 72 is obviously from here is 36 times 2. This 36 is going to come out as 6. Isn't that lovely? 6 root 2 over 6. Now you can divide each term by 6 and you end up with 1 plus or minus the square root of 2. Now for the last one, again, this is, I'm going to leave it to you to finish, but let's see. Here we have fractions. Again, I am definitely not going to work with fractions. So what are we going to do? We are always going to multiply by the least common factor. What is the least common factor? Here is 35. So I'm going to multiply each term, each term by 35. And then if you do that, here's what happens. 7 goes into 35 5 times, so 5x squared plus this goes with that, so only x minus 35 equals 0. And now this is much easier to work with, so I'm gonna leave it to you to work it out and give me the final answer. I'll put it here for you so you can check your work. It's -1 plus or minus the square root of 701 all over 10. The next method is called the graphing calculator, and we will not do it now, but just to know that there is a graphing calculator method where we can find the answer, factoring or solving quadratic equation by the graphing calculator. We're gonna wait until chapter 3 to do it. So the last thing in this section is actually solving for a variable. So the whole idea is to be able to solve for anything. Okay, so solving for a variable. There's one example done for you. Please make sure you read it. I'm gonna do 2 together. Let's look at this one. Solve. Capital V is equal to 1/3 pi lowercase r squared by lowercase h for r. And why am I saying lowercase and uppercase? Because when we are talking variables in math, the capital A is different than lowercase a and so forth. So be careful not to change from capital letter to lowercase and vice versa. So I need to solve for r. So the idea is to isolate r. But first I see that 1/3. We hate fractions. So what are we gonna do? Multiply both sides by 3. So we're gonna get 3v equals, so when we multiply by 3, we got rid of the fraction and we get this. Now again, we're isolating r. So since r is multiplied by pi and h, I'm gonna divide both sides by pi and h. So I'm gonna get r squared is equal to, so I moved the r squared to the left hand side, is equal to 3v over pi h. Now it's really important to remember all the methods we worked and all the things we talked about. Here it is. Now I have r squared equals something. So if you back to remember, our square root property tells me that whatever variable that is squared is always equal to plus or minus the square root of 3v over pi h. And that's absolutely not simplified. Why? Because this is plus or minus. If you separate it, we have a square root in the denominator. We can never have square roots in the denominator. If you remember, the word is rationalize. So we need to rationalize the denominator by multiplying it by top and bottom by the square root of pi h. So now let's see what is left. So r is equal to plus or minus, the numerator is the square root of 3v pi h, and the denominator, when you multiply a square root by a square root, that's the whole idea why it's called rationalize, because a square root squared, all you get is pi h. Okay, let's look at the last example of this section, big section, example 27. And I did lots of examples. Hopefully this is all going to be helpful for you. We need to solve for y, but if you look at this problem, we have 2my squared minus ny equal 3p. So the y is appearing twice in the same equation. One time it's squared and one time it is not squared. When we have that case, the only way to solve it, because it's all variables, so it's hard to complete the square, it's hard to do all these other methods. The easiest method to do it, to do this example, is the quadratic formula. So the first thing is we're going to rewrite it all on one side. Make sure it's equal to 0. And now we're going to specify the a, the b, and the c of our formula. If you remember, the a was the coefficient of y squared. So what's the coefficient of y squared? It's 2m. B is the coefficient of y, and it is negative n. And the c is the constant, meaning doesn't have a y. Remember, our variable is the y, not x in here, which is negative 3p. So now let us put this all. So y is equal to negative b, negative n, plus or minus the square root of negative n squared minus 4 times a times c all over 2 times a. So there's gonna be a limit to how much we can simplify, obviously. So let's see. Y is equal to positive n plus or minus the square root of, so negative n squared is n squared. I have a negative here times a negative, that's gonna make it a positive. Now multiply constant. 4 times 2 is 8, 8 times 3 is 24, and I have m times p and all over 4m. And there's nothing else we can do after that, so that's the simplified final answer. All right, thank you. Actually, wait, I just noticed that I have not finished the first one, and I did that in purpose. So I solved for the d squared just to show again how the rationalizing and the plus or minus are so important. So d is equal to plus or minus the square root of 4a over pi. Okay, so this is equal to plus or minus, the 4 comes out as 2, and then there's a square root of a over the square root of pi, but we need to rationalize the denominator, so multiply top and bottom by pi. So the final answer is d equal to plus or minus 2 the square root of a pi all over pi.